Let's get started since we're just on time, and I will face a bit of a challenge here since there are a lot of subjects to touch upon. And I'm actually now used to giving this as a workshop session in a 2-hour format the past 4 times, so I need to readapt to our conference format of 45-50 minutes today. All right, welcome from my side to the Spring Framework 5 session this afternoon. I'm going to talk about a selected set of themes that we chose to focus on. Those are not just Spring-specific themes, they are largely Java ecosystem themes, industry trends that we are adapting to, that we are kind of embracing on our end into the Spring programming model, into the Spring ecosystem in general. You might be aware that Spring Framework 5 is currently in its milestone phase. We released 5.0 M5, so we are just about to go RC1, so to enter the release candidate phase in a couple of weeks. Late April at this point is our RC1 target. So this comes very timely. We are about to wrap up, about to declare Spring Framework 5.0 feature complete. This presentation is not just 5.0 specific though. It's not a feature overview. It's not a what's new in 5.0. It's about themes that are going to be with us for several years to come. From my perspective, for the entire 5.x generation. So what we're starting here, what we're starting to embrace here in 5.0 is going to evolve, going to be refined in 5.1, 5.2 as we usually do. You might be aware that in Spring we have at least 1 feature release per year in recent years. So our typical release iteration is about 9 to 10 months at this point. So 5.1, we actually expect an RC1 for Christmas this year still. So 5.1 isn't far away either. All right, couple of words on myself. I've been doing this for a long time. I had the pleasure and the privilege to serve as the Spring Framework project lead and kind of the framework architect behind the core Spring Framework for many years now, since its inception back in 2003. And I'm also ultimately responsible for this revision towards Spring Framework 5 for the core framework. So what we're talking about today is on GitHub, Spring-Framework, that project. I am going to wrap up at the very end with a couple of notes on other ecosystem projects that really matter for this story and matter for the themes. But the core framework, the Spring Framework project, is where these things are starting. All right, let's get into it. Let's start with JDK 9. Because, well, first of all, I'd like to get over it. We're going to spend more time on functional and reactive in particular. But JDK 9 is, of course, an important, well, an important happening, right? We are supposed to get it in July this year. And it looks like that's actually happening in the sense of it is being enforced from a release management perspective for it to actually deliver in July. That's, from my perspective, great, but JDK 9 is a bit of a troubled release due to its focus on Jigsaw, the module system. So the most important part of my own take, of my recommendation towards JDK 9 is don't look at it just as a Jigsaw release. Even if people tell you Jigsaw is the JDK 9 theme, the central feature area, that may be true in terms of the effort spent. I don't see it as a particularly good judgment in terms of the benefits that we can reap. So JDK 9 is not just about Jigsaw. It comes with many general improvements, in particular at the JVM level. The internal decomposition, of course, that Jigsaw brings to the JDK itself is a value in its own right. But the application level use of Jigsaw, we're going to talk about it in just a moment, is a different topic. So my recommendation is embrace it. There's no point in fighting it. Embrace the upgrade. Put it onto your upgrade roadmap. Try to be forward compatible with JDK 9. Test your applications. Test complete Spring, Hibernate, whatever based applications on a recent Tomcat release on JDK 9. Just switch the Java home to JDK 9 and run the app again. Don't even recompile it. There are transparent benefits to get out of even this kind of upgrade. There's the compact strings enhancement. There's a significantly better memory representation of simple string encodings at runtime, like half the size for simple ASCII encodings, basically. There's the segmented code cache, the G1 garbage collector enhancements. There's a lot coming with JDK9 that our applications can transparently benefit from simply by being run on a JVM9. By all means, that alone is worth it. So Jigsaw, of course, is the module system that comes with JDK9. And it basically comes with two directions. Right? The initial direction was to decompose the JDK itself into modules. We can transparently benefit from that. We don't need to use Jigsaw in our applications. There is still some value coming out of the modularization of the JDK itself, just by running on it. That's kind of cool, and improves the startup time of the JVM just a little bit. So for a smooth upgrade to JDK9, that is actually what I recommend. Just take the existing app as it is, stay on the class path, upgrade to JDK9, initially even with source 8 language level, consider upgrading to source 9. There are some nice little refinements in the language, in particular in terms of where you can put annotations. These days on collection element declarations, for example, that sort of stuff. There is quite a bit of stuff that you can embrace out of later language levels. Don't be conservative on the language level. There's new API features, of course. There's map of, set of, list of the factory methods on the collections. That's great. Use them. Of course, you don't even need to be on the source 9 language level for that. You can just compile against JDK9 the API level with source 8 and use those methods nevertheless. Anyway, so there are many ways of embracing JDK9 as an upgrade path. So what about Jigsaw? Jigsaw is an interesting effort. It comes with a motivation to deliver an application level module system. There isn't really a particularly strong driver other than the JDK itself, the JDK team itself aiming for application level usage of Jigsaw. Because in practice, there is OSGI out there. Many server systems are internally based, application servers are internally based on OSGI. But application level adoption of OSGI hasn't really taken off. And we have tried. Anyone remembering SpringSource DM server? A while ago. So what about Jigsaw now? Jigsaw is a fine technical effort. Don't get me wrong. In terms of the design, in terms of the technical implementation, in terms of the feature set being well-defined, not trying to be too many things to too many people, not doing provisioning, not knowing about repositories, not managing different versions of libraries at runtime. It's a significantly streamlined version of a runtime module system. But it nevertheless is a runtime module system. And this comes at a cost. You're going to suffer when you're trying to embrace Jigsaw, unfortunately. So from a Spring perspective, we are doing everything we can in general to run fine on JDK9. We've been working on this for 1.5 years. That's great. For a start, right? We basically put it onto your upgrade path. You just need to be in a reasonably recent framework release. That's all really. Even for the 3, right? For the 3 line works fine on JDK9 in general. But what about Jigsaw, right? Well, we have a strategy for the time being. We allow you to opt into the module system by putting the framework jars, Hibernate jars, any Jackson jars, any jars that you need, basically your entire dependency arrangement, onto the module path. JDK9 comes with a class path mode of bootstrapping and with a module path mode of bootstrapping and compiling. So on the module path, we are going to participate in the actual module arrangement without shipping module descriptors. JDK9 calls this automatic modules. If things remain the way they are today, this is a fine migration path. You can just put any existing frameworks and libraries onto your module path, as long as they are generally JVM 9 compatible. You can put them onto the module path. The JVM is going to retain structural information about all the modules deployed, about all the jar files, their boundaries. It will derive a module name from that jar name. So it is a different mode of operation. Even then, even without any specific module descriptors involved, it is a different mode of operation. Instead of this flat class path with directories and archives, but basically it's all flat. The JVM doesn't really retain any information about the structural boundaries. It does so in Jigsaw, and it does so if you put existing jars, framework jars, on the module path. So there is some value in this, just by going onto the module path. There is an enforcement of exported classes not overlapping. There is some startup time early validation with early failures in case of unwanted outcomes, which may happen so easily on the class path. So there's some value even there. What we're trying to enable is application modules being declared with module descriptors and referring to framework jars, Spring framework jars in this particular case, through their module descriptor. So in all brevity, this is a module info file, module info Java. You compile it along with package info Java in your own modules. You ship it in your own jar files. And if you put that jar file onto the module path, the JVM is going to evaluate that module descriptor. It's going to infer visibility rules. You're going to see all the modules that you declare as required. And you're not going to see any other. So modules, of course, come with a formal requirement of you being very aware of what you depend on, what you need to see. Just a couple of hints if you're trying this. This works already. Framework jars without module descriptors is totally okay, even if you are trying to use module descriptors in your own jars. That's actually a quite fine combination at the moment. Where does the name come from then? In the automatic module mode, it's derived from the jar name. So if you take the Spring JDBC 5.0.0.jar from Maven Central, the JVM is going to drop the version information. And it's going to replace the dash with a dot. So that's how you end up with Spring.jdbc, the same naming style as the JDK's own modules, java.base, java.sql, same naming policy. This is not totally set in stone yet. Recommendations around module names may change. It's one of the central areas of debate at this very point still. All right, so you can do this already. Download the latest JDK 9 build, download Spring Framework 5.0M5, put everything you need onto the module path, declare such module descriptors in your own application modules. You have to rely on the naming policies for automatic modules in this kind of arrangement, but you can benefit from a modularization arrangement. This is fundamentally the story. So we actually recommend to stay on the class path. In quite a few cases, you can't avoid that anyway. If you're on Tomcat, if you're deploying a WAR file on Tomcat, you're naturally on the class path because Tomcat always boots in class path mode, like all other application servers and all other deployment environments at the moment. But if you're interested in adopting modules for particular architectures, for particular systems where you control the bootstrapping process, consider opting into Jigsaw. Spring Framework 5.0 and even for the 3 to quite some degree are totally ready for both modes of operation. And don't forget, upgrade to JDK 9 in any case, even if you don't care about Jigsaw. All right, somewhat connected to this, and as quickly as it makes sense today, HTTP 2 is a ongoing theme for us, and it's not something we actually implement in the core framework ourselves. It's more a compatibility issue with the recent generation of servlet containers, with the recent generation of programmatic client libraries for HTTP clients, and it's something we generally care about. Efficient web architectures in 2017 and onwards do not make sense without HTTP 2, at least in general. I am pitching a little, I know. But I really care for industry standards such as HTTP 2, the first revision of the central networking protocol that we are using at the application level, the first revision in 20 years, the first major revision anywhere, right? Except for clarification fixes. So there is a lot of value coming with it, and I'm not going to reiterate all of them in any to any degree of detail. These are transparent benefits. So don't forget, HTTP2 is actually, for application development purposes, almost totally transparent. The only exception to the rule is resource pushes, and even that, if you configure it based on server policies, where the server does some correlation of which resources usually follow after an initial resource, you can leave it up to the server. So server heuristics, even for push, there is no need to explicitly code this anywhere in the applications usually. And it's actually the least interesting feature anyway. The binary representation, the connection multiplexing, the headers compression feature, where finally we're not sending the same text headers on every single request from the same client, where we're just saying like quick reference to the same headers as in the previous request, a quick symbolic reference. I mean, those features are so obvious and so necessary in order to efficiently use our networking resources out there. So by all means, put HTTP2 onto your roadmap if you haven't got it there already. So how do we get there? Well, most stakeholders did their job. The browsers, the mobile browsers, most of the networking infrastructure out there. Unfortunately, we are lagging behind. In the Java middleware ecosystem, there is a tendency to always wait for enforcement by somebody else, in particular by the PDF documents coming out of the JCP. So everybody seems to be kind of focused on Servlet 4 finally delivering an HTTP2 story. Let's quickly revisit what Servlet 4 actually does. It enforces HTTP2 support in Servlet containers. Nowhere does it say that Servlet 3.1 containers couldn't support HTTP2 already. And the only API level feature that's related to HTTP2 in Servlet 4 is a push builder, which, by the way, we support in Spring Framework 5.0 and 5 already in Spring MVC handler methods. End of note. But the push builder isn't actually that interesting. I don't have good use cases for you when you should be doing this from an MVC endpoint. It's up to you to architect your client-server interactions, and if you want the push builder, it's there for you if you're on Servlet 4, like on a Tomcat 9 milestone. But that's the only HTTP2 related feature in Servlet 4, API feature. For all other purposes, it's totally okay to take a Servlet 3.1 based application, run it on a modern Servlet 3.1 container, configure that container for proper HTTP2 connectors, proper HTTP2 protocol setup, that's actually the hardest part, and run it. There is no need to wait for Servlet 4. Waiting for Servlet 4 is basically an excuse. Servlet 4 is a nice bonus to have, a nice enforcement to have, a nice little API upgrade to have. It really isn't particularly interesting. The more interesting part is the actual containers. And Tomcat 8.5, JD 9.4, recent versions of Undertow and the Wildfly server on top of it are all, at least all, come with options where they can be HTTP2 enabled on JDK 8 already. Make use of this. It's a bit convoluted, I admit that, right? The setup instructions differ. You need to actually modify your JDK installation, upgrade the SSL stack accordingly. It is doable. It probably will be easier rather soon, because Oracle actually promises a JDK 8 update sometime later this year, where the JDK 9 protocol stack, the updated ALPN stack from JDK 9, is actually backported to JDK 8. Once we get that, it's totally straightforward. It will be totally straightforward to deploy like Tomcat 8.5, JD 9.4 and co. in their HTTP2 incarnation on the most recent JDK 8 update, and finally allow your clients to talk HTTP2 to your service and not force them to downgrade to HTTP 1.1 every single time. So that's basically our focus. It starts at the framework where we integrate with OK HTTP3 as client libraries, where we support JD 9.4 and Tomcat 8.5 for our server integration. It is fundamentally a job for the application architecture, for the application architect to finally revise, or actually for the deployment setup, for the operations setup even, to finally go HTTP2 there. We have been doing anything and everything we can on our end. Also in Spring Boot and related projects, it really is, basically everything happened that you need to have happened in order to consider the actual HTTP2 stack upgrade in your environments. So let's move on from the rather infrastructural focus to a more of a programming model focus. We have a functional theme in Spring 5 and related projects. What do we mean by functional? Well, simply speaking, we mean the same functional as in Java 8's functional style. So Java 8 with Java util streams, with Java util optional, with lambda expressions and method references, of course, used in combination, collection streams, that style of programming as an inspiration on and kind of revisiting the core framework architecture. The core framework architecture as well to some degree, but in particular the core framework APIs on our end towards more functional usage styles. We actually take this pretty far. We don't just go Java 8, we also consider Kotlin as a recent newcomer in terms of functional languages on the JVM. Kotlin's functional style, Kotlin's functional support is stronger than Java 8's. Not just stronger at the source code level, it in particular is stronger at runtime level. There's more retention of the functional context in Kotlin. We can do smarter introspection of your code and of your invocations when we are running in combination with Kotlin. We're going to see that in just a moment. So as an initial example, let's have a look at bean registration, the very core purpose of Spring's application context. You need to configure it with several beans that you register. You can do so through the good old XML bean definitions. You can do so through explicitly registered annotated classes. You can send the container onto the class path and let it scan for annotated component classes. You can also let it scan for specific types or other kinds of metadata. It doesn't have to be annotations. So there's already a pretty rich arrangement there. And the central entry point is called generic application context. That's actually a pretty old class. In generic application context, we had methods like register bean definition, like in the subclass annotation configure application context, we also have scan and register by class methods. We revisited that API now, where we have register bean variants that are still programmatic, of course, but programmatic with a stronger functional notion. So in the simplest possible case, you would still just register a class and we would apply default rules, like if there's no specific setup, then we would use the default constructor and so forth. We would derive a bean name from the class name. We do our thing, basically. Very similar to the annotation-based conventions, but not actually using annotations at this level. So at least in the straightforward case that we're seeing, that we have a sketch for here, we do not use any annotations. You can mix and match it with annotations if you choose to do so, but you don't have to. You can also do purely functional setup. So along those lines, if you then register another component class, you may supply what we call an instance supplier, a lambda expression against the Java util function supplier interface in this particular case, where you provide a callback for creating a new instance of this particular component class. It's actually very straightforward. It's very trivial, really. But it is baked deep into the container. If the container understands that there is an instance supplier, we are going to immediately dispatch out to that instance supplier. We're not going to reflect upon the constructor setup. We are not going to try to select the constructor and to resolve constructor arguments. Straightforward dispatching to this supplier. So it is a very efficient, actually the most efficient possible way of instructing the container with a particular constructor to use. So we are instantiating bar. We are passing in a foo reference into bar. We are not in the annotation-based world, so we don't let the framework reflectively figure out there's a bar constructor with a foo argument, it's at auto-wired and it needs to be resolved. We explicitly instruct within the callback the framework to do a call back to its factory API, get bean, give me the bean for foo.class. Of course, you may use any retrieval API here, so you could do more sophisticated lookups, but in simple, straightforward arrangements, lookup by class is totally okay. You could also look up by name if you need to differentiate between different instances of the same class, etc., etc. So this is kind of the basic idea. There are a couple of interesting twists in how far we're taking this. For example, down here, there's an extra line, an extra lambda expression. We call this a bean definition customizer. It's actually a var arg of bean definition customizers. You can have any number of such one-line customizers. You basically get the bean definition outcome of the underlying registration process, and you may fine-tune its metadata, like set lazy init, add qualifiers, do any kind of revision of the bean definition metadata as you see fit. There's another little twist here, which I find, I mean, it's a subtle twist, but I find it quite nice. We are specifying an instance supplier even for the simple foo case, where we intend to use the default constructor. So we don't leave it up to class new instance, basically. We instead specify a Java 8 method reference to the particular default constructor on foo. This is technically different at runtime. At runtime, we have an instance supplier. The Java compiler actually bakes it as a synthetic method into the class file with a straight invoke dynamic dispatch to that method. There is no reflection involved. So class.newInstance is kind of reflection, right? Still, and this is a straightforward dispatch to the foo constructor. We are taking a rather extreme position here, right? No annotations, avoiding reflection. I mean, in this kind of arrangement, there is no runtime reflection. It may come in once you start proxying, but you don't have to proxy. There is no reflection in the bean definition in the bean instance creation process. So this is basically a facility at the programmatic level, which is a refinement of existing programmatic registration mechanisms. It's quite nice for, in particular, smaller, focused, tightened application context setups towards maybe microservice architectures where there are only a few components in a particular application context. Maybe towards test setups where you have only a selected arrangement of components to register. And of course, you may combine it with annotation-based configuration at any point, even just by starting with the annotation config application context, which happens to have the same methods. You can functionally register beans and instance suppliers even for annotated components. You can register some components in functional style and register others by annotation-based convention or by class path scan. So this is Java 8, and for the sake of timing, I'm going to show you the Kotlin version quickly, and then let's move on to Reactive. So the Kotlin version is kind of a bonus. We decided to embrace Kotlin rather late, back in December, but it turns out to be a really nice fit, in particular with the registration mechanism, also with the functional endpoint mechanism that we're going to end with today. It is a nice little influence onto our design mission here. So this is the same code in Kotlin style. This is what we tend to call the Java style of using Kotlin. It looks very similar, right? You don't have to repeat the bar argument if you're looking closely, because we can reliably infer the bar return type from the Kotlin function. This looks a little like a Java lambda expression, but it is actually more than that. It is a Kotlin function with Kotlin's reflection delivering some really proper context for that function, whereas we can't infer the return type of a lambda expression, at least not reliably. So Java 8 is limited in that respect. Kotlin is richer. And we make good use of this. We have overloaded signatures, taking k-class arguments, taking k-functions, where Kotlin-specific reflection mechanisms can be used for a more concise, more idiomatic experience if you're coding in Kotlin on your end. We are delivering this in the form of Kotlin extensions. So just to avoid any misunderstanding, the generic application context itself does not have Kotlin-specific overloaded methods. We deliver those as Kotlin extensions that we ship along with our jars, with our standard jars. The Kotlin compiler automatically picks them up and simply speaking, it adds the overloaded methods that those extensions declare to existing Java types when being used from Kotlin. It's a totally nice mechanism where we ship the extensions, the Java compiler completely ignores them. Of course, you don't need to have Kotlin on, in your runtime environment if you don't use it. But if you use it, and if you choose to use Kotlin for compiling your own source code, then the Kotlin compiler, by convention, picks up those extensions that we ship. And we ship extensions not only for the application context and bean factory levels, we ship them for REST template, we ship them for the router functions, we ship them for quite a number of APIs where there can be value added through Kotlin-specific overloads in particular. So what we can see down here is what we tend to call the Gradle style. That's not an official name, of course, but it is similar to the style that's being used in Gradle build files when coding them in Kotlin. So this is just a language variant. Same underlying signatures, same extensions. Kotlin also allows for this kind of nicely nested arrangement and the inline types. I admit that personally I really don't have an issue with the Java style of Kotlin, but this of course isolates the calls to the surrounding variable a little bit nicer. So you can do anything you want with the Kotlin language, and in particular anything that future revisions of the Kotlin language will allow you to do against the Kotlin extensions that we decided to ship in Spring Framework 5.0. So let's get into reactive. In 2015, we started a research initiative where we started to explore a reactive variant of Spring's web stack. This was strongly motivated, kind of initially motivated by the manifesto. I'm not personally that much of a fan of manifestos. But the Reactive Manifesto was an important step and a trigger for some industry collaboration that followed. And it does get quite a few characteristics spot on, right? From our perspective, we do want to deliver another variant of a web stack with particular qualities, in particular in high load scenarios, in unusual load scenarios, with a very high number of concurrent clients, in web scenarios where servlet containers do not shine, where servlet containers tend to have unpredictable behavior at some point, where a reactive processing architecture may deliver very predictable behavior, very reliable behavior, as responsive as technically possible, not artificially rejecting requests when the entire thread pool is already busy, always being ready to accept new simple requests and immediately serve them if you can, even if other requests are currently blocked waiting on an external system. This is the decision towards reactive architectures is a rather complex topic in its own right. From our perspective, we aim for a reactive web stack delivering responsiveness and resiliency to the degree that's technically possible in reactive processing architectures without being constrained by servlet containers. And beyond the manifesto itself and its nice alignment of terms, we are strongly based on what followed, on the Reactive Streams initiative. Reactive Streams is a simple specification, basically a processing architecture and interaction model between publishers and subscribers that's used underneath reactive web stacks, reactive web frameworks. So for our purposes today, you're not going to code against that level. You're going to code against the reactive web framework or a reactive composition library like RxJava. But underneath the covers, recent reactive data store drivers, recent reactive HTTP connectors and reactive web frameworks are all based on reactive streams. So the fundamental idea is very simple. We allow for flow control driven by the subscriber. We build reactive streams publishers, which are basically can be composed publishers, like a whole processing pipeline from a particular data store, looking up a piece of data, transforming it to a JSON document maybe, and rendering it out to an HTTP response. But not coding it step by step, but building a processing pipeline instead, returning this to the runtime stack, and the runtime stack is then able to register a subscriber, like for the HTTP response. And only when the subscriber is being registered, the publisher starts publishing. Well, only when the subscriber actually is registered and starts asking for data, because the subscriber is in charge. Whenever the subscriber says, yes, I can process further chunks of data, further elements towards my output channel, there is no congestion on the output channel, I know I can process a few further elements, then it asks the publisher to deliver those next few elements. So the publisher doesn't just pump data towards the subscriber without listening. It reacts to the subscriber's ability to actually process the data further on, to actually forward the data to whoever asked for it, right? Whoever requested it in the web architecture case. This model underneath the covers is called back pressure, or a subscriber-driven flow control, whatever you prefer to call it. It is an essential part of modern reactive web architectures, web processing stacks, because we allow for a completely non-blocking processing experience. There is no blocking here. We do not actually trigger blocking operations anywhere. We do not just write to an output stream and hope that the output stream is actually able to send the data onwards, where the write method on an output stream might block once the buffer is full and we can't forward it. So no such experience is to be found here at all. A non-blocking processing architecture from top to bottom and back up, based on reactive streams underneath the covers. The way that we integrate this into the Spring Web Stack arrangement is worth a few extra notes, because we actually have two parallel web stacks in Spring Framework 5. The servlet MVC stack remains. The servlet-based Spring Web MVC framework with all its qualities and all its constraints is still available in Spring Framework 5 and will be available going forward. I would even argue it will remain the mainstream option for the foreseeable future, because a highly tuned servlet container with a fine-tuned web architecture on top, aggressive use of HTTP caching, that can be perfectly good enough for many scenarios. There's absolutely nothing wrong with it, and it is very straightforward to code against. It's straightforward to use thread-bound transactions, blocking data store APIs like JDBC and JPA. If you're in that world and if you're constrained by, for example, use of such data store APIs, stay on the servlet stack. You're going to have a much easier experience, much nicer experience. Try to tune the stack accordingly. Try to make use of circuit breakers and in particular of highly efficient caching strategies. And this might be good enough for your purposes. So on top of Spring Web MVC, there's of course the programming model, add controller, add request mapping style controllers remains in place. We have a few refinements, a little bit of reuse of code, but in general it's the same, an evolution of the same servlet-based Spring Web MVC as you know it, with all SPI contracts, the time-diff integration, everything out there in the ecosystem keeps working. In parallel to that, we have a separate web stack based on a reactive HTTP abstraction of our own, right? This comes with Spring Framework 5. It is not only based on reactive streams, it's based on the previously quickly referred to Project Reactor. Project Reactor is a pivotal sponsor project where we have the like 2 full-time committers on it. Reactor is a sort of tightened up version of RxJava, of RxJava 2 in particular. A Java 8 based and server focused composition library for reactive types. So basically RxJava 2, but not with Java 6 and Android compatibility, Java 8 server oriented, half the size, and only 2 reactive types that you typically code against. We are internally using Reactor as our processing kernel. We are also exposing Reactor as at least a choice of reactive types for you to code against. All of this lives in our abstraction layer. We have a new variant of our web framework on top called Spring WebFlux. WebFlux is basically what WebMVC is for the servlet stack. It is your entry point. It is your programming model on top of the reactive stack. And to the degree that's feasible here, it is syntactically and structurally aligned with a Spring Web MVC. So you can use the add controller programming model, the structural familiarity of that programming model, with a different purpose of your handler methods. We're going to see that in a moment. And we also have a programmatic functional way of consuming the same stack. So that's the web framework itself, the abstractions underneath, project reactor as the kernel, and well, we need an HTTP engine, right, at the bottom. There's a choice of 4, where we have first class support for, Tomcat, Jetty, Netty, and Undertow. So you might wonder, Tomcat and Jetty, aren't those servlet containers? What are they doing over there? Well, we are not actually using Tomcat and Jetty as a servlet container here. We are using them as an HTTP engine, as a perfectly reactively capable HTTP engine. Tomcat itself doesn't let go of the servlet API. It's internally still integrated with servlet API types and everything, but the servlet API does not leak through here. So the servlet API may shine through here to the very top. You can declare servlet request arguments in your MVC handler methods, right? The servlet API is a detail here within this layer. It doesn't even shine through into this layer. So we are using Tomcat and Jetty as a reactive HTTP engine with actually native Tomcat and Jetty support. We are using some functionality from the Servlet 3.1 async IO API, but we're using the native Tomcat and Jetty data buffer model and native Tomcat and Jetty bootstrapping in Spring Boot. So those are actually really fine options. In particular on Tomcat, we have a dedicated person now, Violetta, who joined the Tomcat team at Pivotal as the third full-time committer that Pivotal employs, where for Tomcat, where she's actually working on improving Tomcat's reactive story. That's great, right? Tomcat isn't just a servlet container. It's all of its HTTP functionality can be used as a reactive kernel, as a reactive HTTP engine. Of course, at the same time, the most powerful option down here is certainly Netty, no doubt about it. I mean, Netty is kind of the most sophisticated, most powerful, most customizable networking stack on the JVM, period. All the other frameworks, web frameworks, reactively minded web frameworks that you may be aware of out there, they are basically on Netty. Redpack, Vertex, Play, there is no other option. Netty, or you code it yourself. But Netty basically doesn't have any competition. With Undertow, we mean, by the way, we don't mean Undertow servlet, we mean Undertow core. Undertow even ships a core distribution without any servlet involvement at all. So with Undertow core, we have a particularly nice target as well for our reactive HTTP abstraction. In practice, Tomcat is a fine default. Recent Tomcat versions have perfectly fine reactive capabilities. If you need more sophistication and more customization in your networking stack, consider Netty. Now it's totally up to you. But those options are not all the same. So it's not like you just replace them. You are going to natively configure them. That's the reason why you choose them, right? So in that sense, we leave that decision up to you. Netty, of course, is a very important target here. It's kind of the whole point of this stack is for it to be natively capable of running on Netty and not just on Tomcat and Jetty. All right, so what does this look like in the source code? And we already have to wrap up the discussion at this point. I'll give you a few pointers where to follow up afterwards. So this may initially look like a Spring MVC controller. Look at the structure, right? It's a Spring managed component type, has a constructor, can have auto-write on the constructor, can have instant state, has the control annotation, has mapping annotations. Those are Spring Framework 4.3 variants of request mapping, so nothing new really, not new in 5. We have nested path variables, so flexible method signatures. But what are those returning, right? This is not a Spring MVC controller. It is just syntactically aligned with the Spring MVC controller model, but it actually is a reactive web controller, very explicitly designed to run on the reactive web stack, on the Webflux stack. The purpose of handler methods in this world is not to take the request, own a thread, process the entire request within that thread, write the entire response, and then let go of the thread, which is basically the servlet model with its central request thread pool that may be exhausted rather quickly. We're not within that world, right? So instead, we have a reactive HTTP HTTP engine and the web framework around it. That web framework is going to take incoming requests, match them against predicates. When the predicate matches, it delegates to handler methods in order to obtain a Reactive Streams publisher for this particular request. So basically, we're calling the handler method, but the handler method is not supposed to process the request. It is supposed to build a reactive processing pipeline, like a chain of transformations for this particular request, and to return it. That's a very quick operation, just building a few objects essentially. So we call like into the get user method here. We take the ID, pass it on to hopefully some repository layer that we have underneath the covers, where the repository can build a basic Reactive Streams publisher for us. And in the simplest possible case, and in the recommended case, we pass it through. We might transform it, we may react to the presence and non-presence and set a specific HTTP status versus the other. That's what we should be doing at the controller level. But for everything else, we hopefully have a reactive data store underneath that we can delegate to. So what are Mono and Flux here? Those are Reactive Streams publishers that come with Reactor. Both of them actually implement Reactive Streams publisher. Mono and Flux are the central reactive types in Project Reactor. Basically, the equivalent of Flux is basically observable, if you know RxJava, and Mono is sort of single and completable combined. So Flux is a hot stream of users, a Reactive Streams publisher for a sequence of users, and Mono is a single user element, a publisher for a single user element or for none. Reactor really only models those two cases, because in practice, you can express everything with those two cases. Whereas with RxJava has about like 7 reactive types in RxJava in the meantime due to its legacy, RxJava 1 versions and the parallel world with the Reactive Streams enabled versions. You may choose to declare RxJava publishers here, right? You can actually declare an RxJava 1 observable here, or an RxJava 2 flowable, or an RxJava single. We reflectively understand the signature. We understand this is a Reactive Streams publisher that we can adapt. We even actually detect the RxJava types and efficiently adapt them to our underlying kernel. This makes, in particular, makes sense when you delegate to existing code, existing drivers that happen to be RxJava based, like the current edition, the initial edition of the Couchbase driver, which is RxJava 1 based, or any other code that you have that's RxJava based, or maybe you choose to use RxJava because you're more familiar with it, because of the experience, because it's a decision that we leave up to you. So this is the annotation-based reactive controller model. It doesn't try to magically abstract anything. It is just syntactically aligned, so for some familiar structure and reusing the same annotations for HTTP metadata, but with a different purpose for the handler methods. So you need to be very aware that you're actually coding a reactive web controller there, but then it is a really nice and flexible programming model. All right, so to give you a glance of a functional version of this, just as an impression, the same code in WebFlux can also be expressed with what we call router functions. That's actually the exact same code, even with its exact same naive trade-offs. So router functions programmatically map incoming predicates to a handler function, next predicate, next handler function, next predicate, basically request mapping to handler function. There are no annotations here, no annotation-based controllers. No, there might not even be a Spring application context. In this version of the code, we delegate to we use a Java 8 method reference and delegate to a method that complies with the handler function signature. So we have a router function builder with a couple of static inputs here, and delegating to handler functions. Handler functions, in the handler function functional interface, has a request coming in and a publisher for a server response going out. So our signatures here need to be compatible with the handler function signature, of course. This is in purpose, we do the same thing that we do in the annotation-based model. We just need to be a bit more explicit, and we need to do it programmatically. There are no flexible reflective signatures here. Actually, there is no reflection here. In the runtime stack, there is no reflection in this particular case. So we take the request, extract the path variable, we send it through a long transformation, we take the string value, convert it to a long, and once we're done with that, we pass that long value into our repository, which is a find by ID long method. This is our body publisher. We pass that body publisher into our response builder, into the body method. So there's a response builder. The response builder says the HTTP status, can set a couple of headers, whatever it needs to do. And then it takes a Reactive Streams publisher for the body, and we return. We leave the rest up to the runtime stack. The runtime stack is then going to register a subscriber for the response. It's going to call our publisher and ask it to process data as it is efficiently possible at runtime without blocking on the output channel or without blocking waiting for the data store. So in this case, of course, it's even more straightforward because we have no arguments to manage. But we live in a programmatic world here. We are actually coding at the same level of abstraction, if you think about it, just with a different set of syntactic conveniences than in the annotation-based case. From the perspective of Java 8, the language, we are using Java 8 method references here. We can, of course, express the same code with inline lambdas. And there's a Kotlin edition as well, which I'm not showing today. So we can take the exact same code, literally, and nest it into an inline Java 8 lambda. Then it's maybe even a little more obvious what the arrangement actually looks like. Incoming route to handler function, route request predicate to handler function, request predicate to handler function. This may even, in this arrangement, may even scale to 4, 5, 6 handler methods. Then you're probably beyond the, where this inlining makes sense. And the delegation model, of course, is much more scalable, right? You can have any number of router functions that you compose, but you can even have like a dozen router functions listed pointing to separate delegate methods or even to separate delegate classes. Nowhere does it say that these methods need to be on the same class, right? You can point to several delegates. You can have central routing logic delegating to separate handler methods. All right, this is what I had for you to had to show you today. A selection of features for Spring Framework 5.0. Everything I've been talking about is in Spring Framework 5.0 and 5. There's actually much more, but to give you an indication of the direction, the strategy, and the drivers for why we're doing this, we have the JDK 9 topic, we have the Kotlin as an inspiration for a different JVM language. We have the a general functional style that we're applying to the framework as an alternative way of instructing it instead of the annotation-based model that we had as the main focus in Spring Framework 4.x. And we, of course, have the reactive web stack. By the way, there's a JDK 8 baseline, which I'm kind of just assuming at this point everything is Java 8 based in this entire programming model now. I've hinted at, in those code examples, at repositories that are able to deliver Reactive Streams publishers for particular data stores. We actually have a project working on this, and that's in our Spring Data project. The Spring Data K release train introduces a reactive repository model, reactive repository interfaces, where you may declare your repository operations with a Reactive Streams publisher, like a reactor flux or reactor mono as a return type, and the Spring Data translates this to the underlying reactive driver. So we can only do this, of course, for data stores where we have a reactive driver. This is the fundamental constraint in this world. So there are many ways to go about it. From my perspective, the decision towards a reactive web processing architecture often starts with the data store. Do you have a reactive data store driver? Is your data store natively capable of being integrated into a reactive processing architecture? If yes, that may be a really good idea to build a web architecture in the same style above. So for Mongo, for Cassandra, for Redis, for Couchbase, we can do those things. We are working even on we're experimenting with the async Postgres driver. We are trying to do everything we can, but it's of course not in our hands. We can only motivate other data store projects, data store vendors to finally deliver productized versions of their reactive drivers. Let's see once this is happening, but fortunately there are a few already. But this is a central piece of the puzzle. A reactive web architecture can only be as good as it can also reach down to third-party systems and to data stores in a reactive manner, using reactive HTTP clients to talk to other microservices, using reactive data store drivers to talk to a reactive data store in a reactive back pressure enabled manner. Of course, you can code your repositories yourself, right? There's no need to use Spring Data, but it's going to be some really nice out-of-the-box convenience brought by Spring Data. And it's all going to be rolled into Spring Boot 2.0, which is kind of the end of the story, literally. Also the end of our roadmap this year. Spring Framework 5.0 is going to go RC1 soon. It's intended for general availability in late June. Spring Data K is not much behind that at all. Spring Boot 2.0 will use a little more time still. So this is more Q4, October, November-ish for general availability then. Because Spring Boot 2.0 picks up all of this. Spring Framework 5, Spring Data K, latest Spring Security, Spring Integration versions which also have reactive web integration capabilities. And it manages the dependencies for all of this. That's actually the hardest part, since quite a few of those things, in particular with the data store drivers, etc., they are in pre-release state still. So to some degree, we need to wait for those pieces to materialize. It's not just our job. It's quite a few stakeholders have to finally release, and we are going to pick up those releases as they become available. And we're going to do a 2.0 later this year. Anything that won't be released this year needs to be picked up in a 2.1 or whenever afterwards. There is a reactive web starter already, so if you'd like to experiment with this, play with this, go to start.spring.io, pick the Spring Web Reactive Starter, which is currently going to deliver a project with a Spring Boot 2.0 snapshot. Ignore that fact for the moment, and it works perfectly fine. So in order to familiarize yourself with what's possible here, both with the reactive web framework itself and with the Spring Data K, that's the greatest starting point. So the Spring Web Reactive Starter on start.spring.io. And Spring Boot 2.0 will have an official milestone 1 release very soon now, within a few weeks. So we are going to be out of that snapshot state in just a moment. All right, well, that basically is the story for 2017 from our end. I see it as a very exciting year. We're going to get a lot of interesting releases, both in the wider Java ecosystem, JDK 9, Servlet 4, Bean Validation 2, the JSON Binding API, our Spring Framework 5, our Spring Data K, our Spring Boot 2.0. There really is a lot happening, lots of major releases this year. I hope you're going to enjoy this year and hopefully some of those releases. And I hope I was able to give you some pointers on where to start with getting your hands dirty with it, and to inspire you to get started to begin with, right? So thanks for your attention. And if there are any questions, please just come up. I'm happy to take them one-on-one in front here. All right, thanks.